linked list. This is the second video in the series. Array static memory allocation. Here we'll see how static memory allocation happens. In this blue color we can see a block of memory which is shown, where first column is memory address with shown in a yellow color numbers, and in second column is a data stored at particular memory location. If you declare an array int a of 5 elements, means what? It will have 5 integer elements like 10, 20, 30, 40, 50, and which will be stored inside this array. Inside a memory, it will allocate a memory in stack area, and it will be a continuous memory allocation. The memory likewise, here you can see at address, memory address 1000, the first element 10 is stored. So if size of an integer is 2 bytes in 16-bit compiler, so 1000 and 1001, these two memory location which combines to 2 bytes will be allocated for first integer, which is 10. The next location after these 2 bytes is 1002, which will be used to store second element 20. At 1004, 30 will be stored. At 1006, 40 will be stored. At 1008, 50 will be stored. So this is how static memory allocation in array with continuous memory allocation in stack area happens, where at very first location 10 is stored, then in continuous locations 20, 30, 40, 50, these elements are stored, and the likewise. This is a static memory allocation. Linked list uses dynamic memory allocation. Let us see the example. So this is a memory block where this linked list is stored. In dynamic memory allocation, memory is allocated from heap area in random fashion. You can see here a single linked list which is having a very first node which is stores value a, and a is stored at memory location 1008. So this is a pictorial view of a linked list. This is actually stored like this fashion in the memory. Here 1008 is a memory address where the first node is residing. Here a is stored as a data, and a pointer to the next node, which is 2012. You can see here 2012 is the address of the second node, and the first node stores value a, and the address of the next node, that is 2012. So hence at 2012 we can find the second value stored, which is b. You can see here in the linked list b is stored at 2012, and this second node points to the third node, which is stored at 3046. So 3046 is there, and this 3046 nothing but is this memory location, and which stores value c and points to the next node, which is 1058. So 1058 is stored like this, and this is nothing but pointer to the next node, and 1058, you can see here 1058 is above the this 3046. So this is a random memory allocation. So 1058 is here, where d is stored at 105, d is stored, and this node points to 6022. So 6022 is somewhere here. So 6022 stores element e, and here you can see this is grounded, means it stores a null value. So at the very last node it stores null value in a pointer field. So the node that contains value e is a last node of the list, and node a, which is stores very first element a, so it is a head node.